Okay, this first question is explained very, 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 very well with Revision Village. If you go to YouTube and type in Revision Village slope fields, or go to this link here, I'm not even going to try to explain it. They do it so well. So, but let's talk about example 11 here. So they've given you a slope field, and this is the derivative here that gives you the slope. Find the gradient of the tangent to the curve at 1, comma 1. So basically, we're going to use this equation here. Um, um, dy dx, and we've got 1 minus something squared minus something squared over, okay, so our x value here we know is 1. So I'm going to replace the x with 1. Okay. And I'm going to replace the y with 1. Replace that and that with 1. And then if I simplify this, 1 minus 1 minus 1 is going to give me negative 1. 1 minus 1 gives me 0, and then 0 plus 2. Okay, so I can't see what I'm doing. Therefore, the gradient of the function, or the tangent, to the solution curve at 1, comma 1 is 1/2, negative 1/2. Okay, so sketch the solution that passes through 1, comma 1. So what we're going to do here is I'm going to put a dot at 1, comma 1. So here's 0, 1, 2. It's right there. Okay, and how it works is you kind of just follow the lines here. So it looks like it's going this way, and then I'm going down, and then it starts going this way a little bit, doesn't it? So if you have something close, that's fine. So now it's like, okay, oh, now I'm going to go this way. So you're just kind of following the slope lines. So there's really not much to slope curves. And if it's a little bit off, who cares? It's close enough. So, anyways, so here's an example. These are slopes between -2 and 2 for this graph right here. And you can see at -2, -2, that's like right here, right? And notice how the slopes are steep. Okay, and so depending where you put a point will determine how your graph is going to look. Notice how the slopes go straight like this. Okay, so these here, they just wanted you to sort of draw the best curve that you possibly could through 1, comma 1. So 1, comma 1 is right there. Same thing on this graph. So look in here. There, it's going to go up something like that. looks like it goes something like that, right? Looks like it goes through the origin and then around something like that, roughly. Like I said, just the general pattern, as long as it looks like it's following the tangent lines. That's what we're doing. Okay. Once again, I'm going to use this equation. Um, and it's at the origin. So at the origin, at 0, 0, dy dx equals -1 plus 0 squared plus 4 times 0 squared over 0 minus 5 times 0 plus 10, which of course simplifies to -1/10, and that is the gradient of the tangent at this point. Okay, and so it's going to go right there, and so we're starting at the origin, and so if it's -1/10, so it's kind of going down a tiny bit, and then it starts to just go up. And then something like that. Okay, let's move it up. The slope field of this is x squared. Find the general solution from the differential equation. Okay, so we're trying to find the general solution of the differential equation. I'm going to say dy dx equals x squared. And then we're going to do what we just did in the earlier section where we multiplied dx on both sides. So I have dy equals x squared dx. And then I take the integral of both sides. And then I get y equals, and this power increases by 1, x cubed, and then 1/3 there, and then plus c. And this is the general equation. All right? General equation. Okay. So now we're going to find the particular solution when c equals 1. So for bi, if c equals 1, we have y equals 1/3 x cubed plus 1. For bi, we have y equals 1/3 x cubed plus -2, or -2. Right? Okay. So sketch these solutions. Okay. So the first one, when x equals 0, y is going to equal 1, right? So we have 0, 1 is the point. We'll do these in different colors. So 0, 1 is right there. Okay. And so if I'm going to draw that graph, it's going to look something like this. Okay. That looks like an x cubed graph if I ever saw one. Okay, and now I'm going to do this one here. So when x equals 0, y is going to be negative 2. It's going to go through right there. And it's going to go something like that. Okay. Number 4. Slope field for this differential is shown above. Sketch the curve that goes through 0, 2. So 0, 2 goes through right there. And if I draw my slope field, it looks like it's going like this. Right? Something like that. Okay. Find the equation of the curve drawn. So, we've got dy. Oh, why did I write like that? Dy dx equals x times y minus 1. So I'm going to divide both sides by 1 over y minus 1 dy and multiply both sides by dx. And then I'm going to solve using differential equations. So now I've got the integral of 1 over y minus 1 dy equals the integral of x dx. Okay. And we're going to let u equal y minus 1 and du equals dy. Okay. So now I can write this as the integral of 1 over u du equals the integral of x dx. And then the antiderivative of 1 over u is natural log of u. And this equals, this power increases, so 2, and then I have to have the 1/2, and then I'm going to put a plus c. Okay. So now we're going to, we want to solve for c. But before that, I'm just going to write this as natural log of y minus 1 equals 1/2 x squared plus c. Right? So we're going to need to convert this to exponential form. To make it easier, always like to write it as log base e of y minus 1 equals 1/2 x squared plus c. Okay, so if I'm going to convert to exponential form, then I'm going to write e to the power of 1/2 x squared plus c equals y minus 1. We converted it to exponential form in order to solve for y. I'm going to add 1 on both sides, so then I get y equals e to the 1/2 x squared plus c power plus 1. And then I'm going to think of this as y equals e to the 1/2 x squared power times e to the c plus 1. We could think of it this way. And then I'm going to let a equal e to the c. And I can do that because e to the c is just a number. And so I'm going to say a is that number. And so now I've got y equals e to the 1/2 x squared times a plus 1. Like I said, a is just some number. And now let's solve for a. And we know x equals 0 and y equals 2, right? So I can plug that in for x and y. So I'm going to say 2 equals e to the 0 times a plus 1. Well, anything to the 0 is just 1, so I have 2 equals a plus 1. So subtract 1 on both sides, and a equals 1. Okay? So, so now I'm going to rewrite this equation. This is my equation with a being 1. So my solution of the curve is equal to y equals e to the 1/2 x squared power plus 1. Okay, and that is the particular solution for this curve. Okay, what is else? Okay. Initially, the velocity is this. So that means time 0 and velocity. So this is at 0, 0. Okay. And if I'm following this, it kind of goes up like this, right? Something like that. So, so it looks like the skydiver approaches a terminal speed of 50 meters per second. Because it's the horizontal line, it doesn't really go beyond that. Okay. All right, let's look at number 12. Okay, use a particular solution passes through here. Find the particular consider this differential equation, which has this general solution. Okay. So using the general solution, y equals c e to the negative x plus x. That's our general solution. We want to find the particular solution. So we're going to let x equal 0 and y equal -1, right? So now this becomes -1 equals c times e to the 0 plus 0. Right? I've made x equal to 0. I've made y equal to -1. And so now I can say that c equals -1. Okay, so now I'm going to rewrite this equation with -1. So we have y equals -1, so negative e to the negative x plus x. And that is my particular solution. Okay, so just like they did in Revision Village, I'm going to give you some of the points, and then we'll calculate a few of them, and then at some point I'll just give you all of them. So we're using this equation here, right? So let's just pick the easiest one. If x is 0 and y is 0, I'd have 0 minus 0 plus 1. So my slope would be 1 at, if x is 0 and y is 0, then the value here when x is 0 and y is 0, we plug that into my derivative equation, 0 minus 0 plus 1, that I'm going to get 1. Okay. When x is 0 and y is 1, when x is 0 and y is 1, I would have 0 minus 1 plus 1. That's going to give me a slope of 0. If x is 0 and y is 2, I would have 0 minus 2 plus 1. I'm going to get a slope of negative 1. Let's do another one here. Negative 2 and negative 2. So I have negative 2 minus negative 2. Well, that's going to become 0. And then plus 1, I'm going to have a slope of 1. Okay. If I have negative 2, if x is negative 2, then I would have negative 2. And if y is negative 1, then I would have negative negative 1, which would be positive 1. So negative 2 plus 1 plus, wait, if x is negative 2, then I would have negative 2. And then if y is negative 1, I would have plus 1. So negative 2 plus 1 is going to give me negative 1, and negative 1 plus 1 is going to give me 0. Okay, and so on. So I'm going to hit pause, or you should hit pause, and then see if you got this correct. Okay, so I calculated these all in advance. Okay, and so then I kind of go down the line. So here we have 2, 1, 0. Let's just go from the middle. At 0, 0, my slope is 1. I'm going to put a slope that looks like 1. When x is 0 and y is negative 1, that's down here, right here, where I'm pointing. When x is 0 and y is negative, when x is 0 and y is negative 1, we have a slope of 2, so it's a little bit steeper. And when x is 0 and y is negative 2, we have a slope of 3. It's a little even steeper. Okay. When x is 0 and y is 1, we have a slope of 0. So I'm just going to put a horizontal line here. When x is 0 and y is 2, it's up here, we've got a slope of negative 1. And you have to go through that process. So when x is 1 and y is negative 2, we have a slope of 4. When x is 1 and y is negative 1, we have a slope of 3. When x is 1 and y is 0, that's right there, we have a slope of 2. Here we have a slope of 1. It's hard to do the slopes of 2, 3, 4, but 1 should be easy because it's a 45-degree angle. And then when x is 1 and y is 2, we have a slope of 0. Okay, so I've done all the calculation. I've done all this drawings in advance. This takes a little bit of time. Okay, and now this needs to go through a particular point. It's going to go through 0, negative 1. So 0, negative 1 is right there. Okay, and my graph, we're going to try to, just like we did earlier, you're going to just try to follow the tangent lines. Okay. Okay. just show you my work and we can talk it through. Okay, so they gave us a general solution and we want to solve for C. We know x is -1 and y is 0, that we can get a particular solution through that point. So here I've taken my general solution and I replaced y with 0 and I replaced x with -1, and then I calculated my C value. Okay, and there's my particular solution that goes through that point. Okay, now I'm going to construct a slope field using this to find my slope. So we've got 1 minus x. So y can change. Y does not affect the slope field, does it? So if x is 0, I have 1 minus 0. That's going to give me 1. So my slope here for all of these is 1. If x is 1, I have 1 minus 1. The slope for all of these is 0 because the y has no effect on the slope. If x is 2, and so on. So I drew all my things, and it goes, as we said, it goes through the point -1, 0, right there. And then we follow the lines and draw the curve. Okay, let's talk about number 7. Okay, so we want to find the particular solution at 1, -1. So I've got this equation here, the differential equation. So I need to use, I need to divide both sides by y, multiply both sides by dx, and I get this line here. And then I take the integral of both sides. 1 over y gives me natural log of y. 1 and the derivative of 1/2 x is going to give me 1/4 x squared, and then plus c. So when x is 1 and y is -1, then notice we have this absolute value here. So absolute value of -1 is 1, so natural log of 1 is 0, and we've got 1/4 times 1 squared plus c. So we end up with c equals -1/4. And then if I'm going to put this into, we're trying to find a particular solution. So our equation is natural log of y equals 1/4 x squared plus c. So natural log is log base e, y equals 1/4 x squared minus 1/4. We just put in this c value here. And then I need to put this into exponential form. So now I can say e to this power, blah, 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 in parentheses, equals y. And there's my particular solution. And we know that dy dx equals 1/2 xy. So if I plug in 0 in for x, this whole thing is 0, so I'm just going to fill that all with zeros. If I plug in 0 in for y, all these are going to be 0, so I just kind of filled that in. And then I filled in things like, so if x is 1 and y is -2, I would have 1 times -2 divided by 1/2. That's going to give me -1, and so on. If x is 2 and y is -2, I'd have 2 times -2 divided by 2 gives me -2. Anyways, I hope this helps, and that's it.